Hello everyone, I hope you are doing well. So in this video we are going to discuss Geeks for Geeks problem of the day, and today's problem is rightmost different bit, and it is an easy level problem. So I know this video is a little bit late, I couldn't upload the video in the morning, so that is why I'm doing it right now, and it's around 1 in the afternoon. So anyways, it says that we have been given two different numbers m and n, and our task is to find the rightmost different bit in the binary representation of those numbers, right? So if the numbers are exactly the same, that means if there are no different bits, then we just have to return -1 in that particular case. So how can we solve this problem? It's very simple, just a simple implementation of a very standard bit masking technique. So what I generally do is, let's say I have a number x, right? I want to find out its 0th bit, right? Whether it is the 0th bit is set or not set, that means it is either 0 or 1. So I want to find out this particular information. So what I'll do is, I'll right shift the value x 0th number of times and take its XOR with 1, end with 1, bitwise end, right? This works for any ith bit. So if I want to find out whether ith bit of x is set or not, what I'll do is, I'll right shift the character I or the integer I times and take its bitwise and with 1. So what will essentially happen in this particular operation? Let's say this is the binary number 0, 1, like this. Right, so this is the 0th bit, this is the first bit, second bit and third bit. Let's say I want to find out the second bit. Now, if I right shift this particular number x 2 times, what will be the result? So the result will be 0, 0, 1, 0. So this whole number will right shift 2 times. So first this will get eliminated, then this will get eliminated, and these two numbers will come at the positions 0 and 1 respectively. Right, and all to the left it will be zeros only. Now I want to find out, that means basically whichever bit was at the 2th position or the 2th index now has come to the 0th index, right? Now I just basically want to find out what is the digit at the 0th index. So again, let me just explain you this part again. What I have done is, I have right shifted the number x I times. So what will happen after this? The digit or the bit which was present at the ith index will now be at the 0th index. Now I can take the bitwise AND of this whole number with 1. So basically it is 0, 0, 0, 0, 1, right? Like this. Only the last digit will be set. So now what I'll have to do is, if I take the bitwise AND, if this particular bit is set, the result will be 1. If this bit is not set, the result will be 0. Why? Because all of the bits are already 0. Now the value of the 0th bit or the 0th bit in the answer depends on this particular bit. So if this is set, the final result will be set. If this is not set, the final result will be not set. So now I can basically traverse through all the bits. If you look at the constraints here, the value of m and n is up to 10⁻⁹. So an upper bound of 32 bits will work on this particular number, right? So what I can do is, I can just traverse through all the bits from 0 to 32. I am finding out whether the ith bit is set or not by doing m right shift I and taking its bitwise AND with 1. Similarly, n right shift I times and taking its bitwise AND with 1. So if x is not equals to y, that means the bit at the ith position in both of the numbers are different. I can just return I plus 1 because the indexing that they have used is starting from 1. Right. Now if none of this gets triggered, I can just return -1 and this would be my final solution. So let me just quickly submit this and show you that this particular code works and the solution is absolutely correct. So you see, it passes all the test cases, and this is one of the solutions of this particular problem. Again, the time complexity will be log of m and n because it basically depends on the number of bits and it's logarithmic with base of 2. So that was it for this particular video. Now if you guys were able to understand the solution, do consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you, more to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.